Okay, good afternoon. Welcome to
Family Math number 302a.
FamilyMath302a. So this is a problem I saw yesterday via a Fawn Wynn tweet, but it's actually not her problem. It's, I believe it's from Annie Fetter, who works at the Math Forum. And she's always got some very cool problems to talk about. So here's the problem. Last weekend I was watching leaves fall from a tree. As the wind picked up, the leaves fell faster, and I noticed the following interesting pattern. During the first minute, only one leaf fell. And then during each passing minute, the number of leaves that fell was equal to the total on the ground plus 1. If the pattern continued, how many leaves fell in the 12th minute and then also the 24th minute? Okay, so before we get going, I want to make sure, do you understand what's going on?
Yeah. So for first minute, one leaf falls, and then during each passing minute, then the number of leaves is equal to the number of leaves in the ground plus 1. So the next minute, it would be equal to the number of leaves on the ground, 1, then plus 1. That would be 2.
Okay.
So we could write the number of leaves that would be on the ground.
Okay.
Total. So.
All right.
So the first minute there would be 1.
Okay.
And then in the next passing minute you add another leaf, and then so that there's 2. Then we have 3. Then plus 1. It's 4. And we have this is 6 plus 1. 7 plus 1 is 8. Now we have 8 plus 4 is 12, plus 2 is 14. This one is 15, plus 1 is 16. Interesting. We're starting to see the powers of 2. I think this kind of relates with binary.
Does it?
Because if you had 1's digit, if you had the digits, the 1's, the 2's, the 4's, the 8's, to get to the next digit, if you had 1 in every one, then you'd have to bring if you had this, then you'd have to add 1 to this. Then it would get to the next number, which is 16.
Oh, wow.
Then you could also...
That's a fascinating observation.
And then we can try to see a pattern that continues with these. So on the first one, we had 1 leaf, and that's 2 to the 0. And the second was 2 leaves, 2 to the first. Then third was 2 to the second leaves. So maybe if you have the nth minute, the number of leaves on the ground, is equal to, it's 2 to the n minus 1.
Ooh, interesting.
So now if we can test this formula for some simple numbers, maybe the third row. If we have the third row, then we found it was 4. And now, so the number of leaves on the ground is equal to n is 3. So 2 to the n minus 1. 3 minus 1 is 2. So 2 squared is 4. So it seems like our pattern, seems like the formula works.
Interesting.
And now it said it was for the 12th.
Yeah.
And the 24th.
The 12th and 24th, yeah.
And now we could figure out this by using the formula. So it was n, so it was n, our formula was 2 to the n minus 1. That was where n is it's the minute number. It was it was like the first, second, third. That would be n.
Okay.
So if the third minute n would be 3. So on the 12th minute, n is 12. The number of leaves on the ground is equal to 2 to the 12 minus 1, 2 to the 11th, which 2048.
Okay.
2048 leaves on the ground.
All right. And what about the 24th minute?
That would be 52 to the 23rd. And can we figure that out? Well, I'm not sure I know what that is. So do we have a calculator?
Yeah, well, maybe you can try to guess or approximate what it is.
Well, it's 2. It would be 2. It's 2 to the 10th times 2 to the 10th is 2 to the 20th.
Yeah.
So it would be around 10,000 would be around 2 to the 20th.
How did you get that? What calculation did you do?
Well, 2 to the 10th is around 1,000.
Yeah.
2 to the 20th is 2 to the 10th times 2 to the 10th.
Okay.
So then we just do 1,000 times 1,000, which is, it's a million.
It's a million, yeah.
So 2 to the 20th is around a million. So then we would add, it would be times 8, so that would be around 8 million leaves.
Okay. Let's leave it at that. Can you write that's approximately 8 million?
This is approximately 8 million.
Cool. Hey, that
That's
was
a
great
lot
work.
of leaves.
It's a lot of leaves, yeah. I would advise you, if you saw this happening, to leave before the 24th minute.
Maybe rake.
Yeah, well, I think the rake might work for a little bit.
Maybe not. You'd have to rake at a very fast speed.
Yeah.
Maybe a leaf blower.
Good work, huh? Good work.